In the silence of space, where there's no air, no soil, and no rain, something extraordinary is beginning to happen. Tiny green leaves unfurl, roots stretch into darkness, moisture glistens in glowing chambers, and for the first time in history, life is learning to grow beyond Earth. It sounds simple, growing food in space. But beneath that simplicity lies one of the most profound challenges in space exploration. Because if we truly want to live on the moon, if we dream of walking on Mars, if we imagine starships ferrying settlers across the solar system, then we can't survive on ration packs and cargo shipments alone. We'll need farms. We'll need ecosystems. We'll need to bring Earth with us. This is the story of how we're learning to grow food in the most hostile environments ever attempted, and why mastering this ancient art may be the key to humanity's future among the stars. Food has always shaped human civilization. Agriculture allowed us to settle. Cities followed harvests. Trade routes emerged from food needs. Every culture, every tradition, every celebration, at its heart, has food. But in space, food is a limiting factor. Today's astronauts rely entirely on food launched from Earth. Carefully measured, packaged, dehydrated, lightweight. It works for now, but future missions will last months or years. A round trip to Mars could take nearly 3 years. Resupply from Earth would be impossible. And more than calories, spacefarers will need nutrients. Fresh produce, vitamins, fiber. The kinds of things that degrade quickly in storage. Then there's the psychological need. The comfort of a fresh bite of lettuce. The smell of soil. The act of tending to something alive. Food, in space, is survival. But it's also connection. Identity. Sanity. Growing it off-world changes everything. The idea isn't new. In 1982, Soviet cosmonauts aboard Salyut 7 grew the first flowering plant in space. It was a mustard plant, not edible, but symbolic, a sign that life could take root beyond gravity. Since then, plant experiments have flown aboard Skylab, Mir, the Space Shuttle, and now the International Space Station. NASA has studied how different wavelengths of light affect growth, how roots navigate without up or down, how water clings to roots in microgravity, how plants respond to stress, radiation, and isolation. On the ISS today, 2 major systems support plant growth. Veggie, a simple, modular greenhouse using LED lights and plant pillows filled with clay and fertilizer. APH, the Advanced Plant Habitat, a fully automated, climate-controlled chamber with over 180 sensors. These platforms have grown dozens of crops. Lettuce, red romaine, for salad experiments. Radishes, mizuna, mustard greens. Zinnias, for understanding flowering and stress. Wheat, peas, dwarf tomatoes. And, in 2021, chili peppers, the first plant grown from seed to fruit in orbit and eaten by astronauts. They even made tacos with the peppers. In space, it's humble, but historic. But every leaf grown in orbit is a triumph over countless challenges. 1. Gravity. On Earth, gravity tells roots to grow downward and shoots to reach for the sky. In microgravity, there is no down. Roots can tangle or float. Shoots twist randomly. Plants get disoriented. 2. Water. Without gravity, water doesn't flow. It floats. It can suffocate roots or float away in bubbles. Engineers use hydroponics, aeroponics, and wicking materials to deliver water directly to roots. 3. Light. Natural sunlight is too intense and unreliable in space. Most systems use LED arrays, tuned to specific wavelengths, often pink or purple, to maximize photosynthesis and minimize energy use. For air, carbon dioxide must be delivered evenly. Humidity must be controlled. Fungal infections thrive in stagnant, moist environments. Space farms must be constantly monitored and regulated. 5. Radiation. Outside Earth's magnetic field, cosmic rays and solar radiation can damage plant DNA. Long-term exposure may reduce yield or change flavor, color, or nutrition. 6. Waste. Plants need nutrients, nitrogen, phosphorus, potassium. In a closed-loop system, astronauts' own waste may one day be converted into fertilizer, a concept that's efficient and humbling. Growing food in space isn't just about botany. It's engineering, chemistry, environmental control, and psychology. Something surprising has emerged from these experiments. Not just scientific data, but emotional depth. Astronauts consistently report that tending to plants becomes one of the most meaningful parts of their mission. It offers routine, purpose, a connection to Earth. In the quiet hum of the ISS, watering a seedling, watching a leaf unfurl, becomes more than biology. It becomes comfort. As missions grow longer and more distant, this role may become critical. Future astronauts, isolated on Mars or deep space missions, will need more than calories. They'll need life. NASA psychologists are studying horticultural therapy in space. The idea that simply caring for a plant can reduce stress, anxiety, and depression, especially when you're millions of miles from home. In a world of wires, modules, and vacuum, a single green sprout may be the difference between enduring and thriving. The real proving ground for space agriculture will be the Moon and Mars. On the Moon, soil is dry, jagged, and sterile. It contains no organic material, and it's rich in glass-like particles and metals. Radiation is intense. Days last 2 weeks. Temperatures swing hundreds of degrees. Mars offers more promise, but also more complexity. Its atmosphere is thin and mostly carbon dioxide. Its soil contains toxic perchlorates, which must be filtered or neutralized. Dust storms can last weeks. But Mars also has what the Moon lacks: frozen water, a partial atmosphere, and some gravity, about 38% of Earth's. Experiments on Earth, including simulated Martian greenhouses in places like Antarctica, Hawaii's volcanic slopes, and biospheres in the desert, show promising results. With the right conditions, plants can grow in Martian-like regolith. Future Mars farms may use inflatable domes, underground bunkers, or even lava tubes for protection. They'll recycle air, water, and nutrients in tightly controlled loops. Crops like potatoes, wheat, soybeans, and leafy greens may be first. Mars will demand innovation, but the red planet may one day host the first off-Earth harvest large enough to feed a community. Space farms won't be like Earth farms. They'll be small, robotic, highly automated. They'll use AI to monitor plant health, optimize lighting and watering schedules, and adjust to crew needs in real time. Robotic arms may harvest crops. Drones may pollinate them. Smart sensors may detect diseases before humans ever notice. And then there's synthetic biology. Scientists are exploring genetically modified crops designed for space. Plants that grow faster, use less water, and resist radiation. Some may even be engineered to produce medicines, vitamins, or therapeutic compounds on board. Fungi, algae, and cyanobacteria may also play a key role, used to produce protein, biofuels, or even materials like bioplastic. In the future, a space farm might look more like a biotech lab than a field. And yet, its purpose will remain beautifully old-fashioned: to feed, to sustain, to give life. A seed is a story. It begins as something small, dormant, packed with potential. Given light, water, and care, it becomes something nourishing, something generational, something that multiplies. To grow food in space is to tell a new story, one of resilience, of life reaching beyond its cradle. One day, a child may harvest tomatoes on Mars. A colony may plant the first orchard beneath a dome on the moon. Starships may carry algae tanks and wheat beds to moons of Jupiter, Saturn, or beyond. It all starts here, with a few lights, a small chamber, a leaf floating in microgravity. The answer to the question, can we grow food in space, is becoming clearer every year. Yes, we can. Yes, we are. And yes, we must. Because wherever humans go, we'll need more than machines. We'll need nourishment. We'll need roots. We'll need something green. We won't just bring Earth with us. We'll plant it.